Hello everyone, welcome to video lecture series on concepts of preemptive scheduling policies. In previous video, we had dealt with round robin scheduling with time slicing. The link is available in the description, you may go through. In this video, we shall go through another preemptive scheduling policy called least completed next, that is LCN scheduling. Let us look into features of LCN scheduling policy. LCN policy or least completed next policy schedules the process that has so far consumed the least amount of CPU time. That is the process that has least completed at a given instance of time. Here the nature of process, that is whether CPU bound or IO bound, and the CPU time requirement of a process does not affect its progress in a system. So, in least completed next scheduling, all processes will make approximately equal progress in terms of CPU time consumed by them. Hence, it is obvious that short processes complete earlier than the long processes. But the drawback of this policy is that long processes suffer from starving from CPU attention. That is, if more and more short processes are injected into the system, long processes will take long time to complete. Also, in this policy, new processes have higher priority over existing processes. So, even not so long processes will also tend to suffer from large turnaround time. That is, we know that turnaround time means sum of service time plus waiting time. So, if more and more new processes are entering into the system, waiting time of the processes will be increased. This will lead to long turnaround time. Let us understand least completed next scheduling policy in deep by considering an example. As it can be seen, there are 5 processes or requests, namely P1, P2, P3, P4 and P5, and their admission times are at 0, 3, 5, 6 and 8 time units respectively. That is, process P1 will be loaded into memory at 0 time units and process P2 at 3 time units. Similarly, process P3 will be loaded into memory at 5 time units, P4 at 6 time units and P5 at 8 time units. Their services times are 4, 5, 5, 4 and 2 time units respectively. That is, process P1 totally requires 4 units of CPU time for its completion. On similar line, process P2 and P3 requires 5 time units to complete their execution. P4 requires 4 time units to complete its execution. And finally, process P5 requires only 2 time units to complete. Now, let us schedule these 5 processes by following least completed next scheduling policy by considering a time slice of 1 time unit. That is, running process will be preempted after every 1 time unit and will be put at the end of ready queue. The scheduler analyzes CPU time consumed by each process and schedules the process that has consumed least amount of CPU time. In case of a tie, that is, suppose at any instance of time, if 2 or more processes have consumed equal amount of CPU time, then the process that has not been serviced for the longest period of time will be selected and scheduled by the scheduler. With this understanding, now let us start scheduling these 5 processes, for which we shall consider a table wherein row 1 shows the time of scheduling and following 5 rows shows the amount of CPU time already consumed by the process P1, P2, P3, P4 and P5 respectively. And last row specifies the process which is selected or scheduled based on least completed next scheduling policy. Hand in hand, let us go through timing diagram where we have time units on x-axis and on y-axis we have processes P1, P2, P3, P4 and P5. Now once let us take a look of question. So we can see that there are 5 processes P1, P2, P3, P4, P5 and their respective admission time and service time. So if you look, process P1 is admitted or it is loaded into the memory at time unit 0, and the next process is P2 which will be loaded into memory at 3 time units. So at 0 time units we have only process P1 in the ready queue and it has been not scheduled even for once. So since there is no other process in the ready queue, P1 will be directly selected or it will be scheduled. So P1 will be executing from 0 to 1 time unit. So at 1 time unit, P1 has completed 1 time unit of execution. So since there are no any other process in the ready queue, again P1 will be selected and it will be executing from 1 to 2 time units. At 2 time units, process P1 has completed 2 time units of execution, and again there are no other processes in the ready queue, so P1 will get one more chance to execute from 2 to 3. At 3 time units, process P1 has completed 3 time units of execution, and there is one more process P2 which has been loaded into the memory and it has not got a chance to execute still. At 3 time units there are 2 processes in the ready queue, P1 and P2, out of which P2 is least completed. So P2 will be selected for execution and it is going to execute from 3 to 4 time units. So at 4 time units, P2 has completed 1 time unit of execution and P1 has completed 3 time units of execution. So out of processes P1 and P2, P2 is one which has least completed. So again it will be selected for execution and it is going to execute from 4 to 5 time units. At 5 time units, P2 has completed 2 time units of execution and there is a new process which is loaded into the memory, process P3, and P1 has completed 3 time units. At 5 time units there are 3 processes in the ready queue, process P1, P2, P3, and out of these 3 the least completed one is process P3, right? So P3 will be selected for execution and it is going to execute from 5 to 6 time units. So at 6 time units, P3 has completed 1 time unit of execution and there is one more new process P4 which has been loaded into memory and it has not got a chance to execute still, and P1 has completed 3 time unit of execution and P2 has completed 2 time units of execution. So we can say that at 6 time unit there are 4 processes in the ready queue, process P1, P2, P3 and P4, out of which P4 is the least completed one. So that will be selected for execution and process P4 is going to execute from 6 to 7 time units. Okay, so at 7 time units again there are 4 processes P1, P2, P3, P4, wherein P4 has completed 1 time unit of execution, P1 has completed 3 time units of execution, P2 has completed 2 time units of execution and P3 has completed 1 time unit of execution. At this point we can say that both processes P3 and P4 have consumed equal amount of CPU time, right? So there is a tie between process P3 and P4. So if you look into the time when they are scheduled, P3 is scheduled at long back compared to process P4. So we are going to select the process which was scheduled long back, right? Or we are going to select the process which was serviced long back. So out of P3 and P4, process P3 was serviced long back where P4 was recently scheduled. So we are going to select process P3 for execution and P3 is going to execute from 7 to 8 time units. So at 8 time units, we have process P3 which has completed 2 time units of execution and there is a new process P5 which has been loaded into the memory and it has not got a chance yet to execute, and P1 has completed 3 time units of execution, P2 has completed 2 time units of execution and P4 has completed 1 time units of execution. So there are totally 5 processes in the ready queue, out of which process P5 is least completed. It has not got a chance to execute only. So P5 will be selected for execution and it is going to execute from 8 to 9 time units. So at 9 time units, we have process P5 which has completed 1 time unit of execution, P1 which has completed 3 time units of execution, P2 which has completed 2 time units of execution, P3 which has completed again 2 time units of execution, and P4 which has completed 1 time unit of execution. So we can see that P4 and P5 both have consumed equal amount of CPU time, that is 1 time unit. So out of P4 and P5, if we look, P5 was recently scheduled where P4 was scheduled long back. So out of P4 and P5, P4 will be selected for scheduling and it is going to execute from 9 to 10 time units. So at 10 time units, we have 5 processes in the ready queue with process P4 consuming 2 time units, process P1 has executed for 3 time units, P2 has executed for 2 time units, P3 also executed for 2 time units, and P5 which has been executed for 1 time units. So out of these 5 processes, we can see that process P5 is least completed with 1 time unit. So process P5 will be selected for execution and it is going to execute from 10 to 11 time units. So if we look into the question, we can see that process P5 has 2 time units of service time. So see here, process P5 was first scheduled between 8 to 9 and again scheduled between 10 to 11. So we can say that process P5 has completed its execution at 11 time units. So at 11 time units, there are only 4 processes in the ready queue: P1, P2, P3 and P4, with P1 executing for 3 time units, P2 executing for 2 time units, P3 also executing for 2 time units, and P4 also executing for 2 time units. So again, there is a tie situation between 3 processes: P2, P3 and P4. So if we look into these things, P2, P3 and P4, we can see that P2 was serviced long back while P3 and P4 were recently scheduled, right? So out of P2, P3, P4, P2 will be selected for execution and it is going to execute from 11 to 12 time units. Okay, so at 12 time units, we have process P2 which has completed 3 time units of execution, P1 which has completed 3 time units of execution, P3 which has completed 2 time units of execution, and P4 which has also completed 2 time unit of execution. So again, there is a tie between 2 processes P3 and P4. So if you look into this, P3 and P4, P4 was recently scheduled while P3 was serviced long back. So out of P3 and P4, P3 will be selected for execution and it is going to execute from 12 to 13 time units. Okay, so at 13 time units, if we look into, we can see that P3 has completed 3 time unit of execution, P1 has completed 3 time units of execution, P2 also completed 3 time unit of execution, and P4 has completed 2 time unit of execution. So out of these 4 processes, we can see that process P4 is the least completed one. So process P4 will be selected for execution and it is going to execute from 13 to 14 time units. So at 14 time units, we can see that process P4 has completed 3 time unit of execution, P1, P2, P3 also completed 3 time unit of execution. So all the 4 processes in the ready queue, P1, P2, P3, P4 have consumed equal amount of CPU time, that is 3 time units. So there is a tie between all the 4. So which process will be selected means the one which is serviced long back. So out of P1, P2, P3, P4, P1 was serviced long back, right? So P1 will be selected for execution and it is going to execute from 14 to 15 time units. So if we look into the question, we have process P1 having service time 4 time units. So if you look here, P1 was scheduled first time, second, third time, and finally 4th time between 4 to 15 time units. So we can say that process P1 has completed its execution at 15 time units. So at 15 time units, we are having only 3 processes in the ready queue with P2 completing 3 time units of execution, P3 completing 3 time units of execution, and also P4 completing 3 time units of execution. So again there is a tie between P2, P3, P4. So out of these three, if you see, P2 was serviced long back while P3 and P4 were recently scheduled. So P2 will be selected for execution and it is going to execute from 15 to 16 time units. So at 16 time units, we have P2 which has completed 4 time units of execution, P3 which has completed 3 time units of execution, and P4 which has completed 3 time units of execution. So out of P3 and P4, P3 was serviced long back and P4 was recently scheduled. So P3 will be selected for execution and it is going to execute from 16 to 17 time units. So at 17 time units, we have process P3 which has completed 4 time units of execution, process P2 which has completed 4 time units of execution, and P4 which has completed only 3 time units of execution. So out of P2, P3, P4, P4 is least completed, so it will be directly selected for execution and it is going to execute from 17 to 18 time units. So if we look into the question, we can see that P4 is having a service time of 4 time units. So if we look here, P4 was scheduled once, twice, thrice, and for the fourth time between 17 to 18 time units. So we can say that P4 has completed its execution at 18 time units. Okay, so at 18 time units, we are having only 2 processes in the ready queue, with P2 completing 4 time units and P3 also completing 4 time units of execution. So there is a tie between P2 and P3. So if you look here, comparing P2 and P3, P2 was serviced long back and P3 was recently scheduled. So process P2 will be selected for execution and it is going to execute from 18 to 19 time units. So again, if we look into the question, P2 is having a service time of 5 time units. So look here, P2 was scheduled once, twice, thrice, fourth time, and again fifth time between 18 to 19 time units. So we can say that process P2 completed its execution at 19 time units. So at 19 time units, we are having only one process in the ready queue, that is P3. So P3 will be directly selected for execution and is going to execute between 19 to 20 time units. So if you look into that, so P3 is also having a service time of 5 time units, right? So look here, P3 was scheduled once, twice, thrice, fourth time, and again fifth time between 19 to 20 time units. So we can say that process P3 completed its execution at 20 time units. And also all the 5 processes completed their execution at 20 time units, right? Now let us consider one more small table with 3 columns, wherein first column shows completion time C, second column shows turnaround time TA, and third column shows weighted turnaround time W for each process. Now we shall find completion time, turnaround time, and weighted turnaround time for each process, which we can find from timing diagram. From the timing diagram, it is evident that P1, process P1 completes its execution at 15 time units. Process P2 completes its execution at 19 time units. Process P3 completes its execution at 20 time units. Process P4 completes its execution at 18 time units, and process P5 completes its execution at 11 time units. So these are the completion times of process P1, P2, P3, P4 and P5. Okay. So next we shall calculate turnaround time. Turnaround time is nothing but sum of service time plus waiting time. Okay. So if you look into process P1, P1 is serviced for 1, 2, 3 and 4 time units, and waiting time of P1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So process P1 is having a service time of 4 time units and waiting time of 11 time units. So 4 plus 11 is 15 time units. So that is the turnaround time for process P1. Similarly, process P2 is having service time of 1, 2, 3, 4 and 5 time units, and waiting time of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So service time of 5 time units and waiting time of 11 time units. 5 plus 11 is 16 time units. So that is the turnaround time for process P2. For P3, service time is 1, 2, 3, 4 and 5 time units, which we can see from timing diagram, and also it is given in the question. And what is the waiting time for process P3? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So service time of 5 time units and waiting time of 10 time units. 5 plus 10 is 15 time units. That is the turnaround time for process P3. For process P4, service time is 1, 2, 3, 4, 4 time units, and waiting time is 1, 2, 3, 4, 5, 6, 7, 8. So 4 time units of service and 8 time units of waiting. 4 plus 8 is 12 time units. So that is the turnaround time for process P4. And for process P5, service time is 2 time units and waiting time is only 1 time unit. So 2 plus 1 is 3 time units. So that is the turnaround time for process P5. So this is how we are going to calculate turnaround time for given processes from the timing diagram. Next, we shall calculate weighted turnaround time for each process, wherein weighted turnaround time is nothing but ratio of turnaround time to the service time. So for process P1, turnaround time is 15 and service time is 4 time units, which we can see from the timing diagram, and also it is given in the question. So 15 by 4 is nothing but 3.75. Similarly, for process P2, turnaround time is 16, service time is 5. So 16 by 5 is 3.2. Similarly, for process P3, turnaround time is 15 and service time is again 5 time units. So 15 by 5 is 3 time units. For process P4, turnaround time is 12 and service time is 4. So 12 by 4 is 3 time units. And for process P5, turnaround time is 3 time units and service time is 2 time units. 3 by 2 is 1.5 time units. So this is how we are going to compute or calculate weighted turnaround time for given processes by applying least completed next scheduling policy. So there are two more terms, TA bar and WO bar. That is nothing but average turnaround time and average weighted turnaround time. So which can be calculated by taking the average of these individual turnaround times and individual weighted turnaround time. So TA bar, that is average turnaround time, is given by sum of these values divided by number of values, that is 5. So 15 plus 16 plus 15 plus 12 plus 3 is nothing but 61. So divided by 5, 61 by 5 gives 12.2 time units. That is the average turnaround time. Similarly, average weighted time is nothing but sum of these individual weighted turnaround values divided by 5. So 3.5 plus 3.2 plus 3.0 plus 3.0 plus 1.5 gives you 14.45 divided by 5 gives 2.89 time units. Okay, so this is how we are going to schedule any given processes using least completed next scheduling policy and calculate completion time, turnaround time, weighted turnaround time, average turnaround time and average weighted turnaround time. So this is it for this video. Thanks for watching. I hope you got a better idea about least completed next preemptive scheduling policy. If you feel it worth it, do like and share so that this video can reach maximum audience. So let's meet soon with a new video and a new concept. Until then, take care and goodbye.